Hello, this tutorial is about practice writing equations. I'm going to show you how to do the balanced, the complete ionic, and the net ionic equations. First, we have a solution here of aqueous lead 2 nitrate and ammonium chloride. They're mixed. They form a precipitate of lead 2 chloride. Because it forms a precipitate, we already know it's a double replacement. But let's write out the reactants. We want to write out all the formulas and states of matter and then balance it. So we see lead 2 gives away 2 electrons, nitrate, so it would be PbNO3 with the 2 as a subscript. It's an aqueous solution mixed in with ammonium chloride, forms lead 2 chloride and ammonium nitrate. Well, the next thing we do is we want to balance it. We see that we have 2 NH4s on one side, so we need 2 NH4s on the other side. So we put a 2 as the coefficient. Remember, we never change the subscripts because the subscripts are indicating that we have a neutral compound. Next, we separate the ions and put in the charges. So we see that lead gives away 2 electrons, so it has a +2 charge. Nitrate takes 1 electron, and there's 2 nitrates, so we have to write down 2 NO3. Then we have ammonium. Again, we have 2 ammoniums, each with a +1 charge, and 2 chlorines, each with a -1 charge. Then lead 2 chloride is a solid. It's the product of this reaction. So we don't break lead 2 chloride up. What has become a solid stays a solid. And then ammonium nitrate is still aqueous, so we have to split that up. So ammonium, there's 2 of them. Each one has a +1 charge. And then there's 2 nitrates, each with a -1 charge. The next thing we're going to want to do is get rid of our spectator ions. You see this nitrate as a reactant is the same form as the nitrate in a product. So nitrate is the spectator. The other spectator is the ammonium, because the ammonium on one side is exactly the same as the other. So we know that the lead and the chlorine are the 2 that reacted. So we would write only those species for the net ionic equation. So lead +2 in aqueous plus 2 chlorine in aqueous gives us lead 2 chloride as a solid. That is the net ionic equation. Let's try another one. Nitric acid and aqueous barium hydroxide. Again, we have 2 compounds and they're reacting to form water. Water is one of the products for a double replacement. We begin by writing all the formula. We see that the formula for nitric acid is HNO3 and the formula for barium hydroxide is BaOH2. We already know they form water, so we know that HOH is one of our products. Well, what's the other product? We're left with barium and nitrate, and remember, nitrates do not go to a solid, they stay aqueous, so we would write aqueous for barium nitrate. Then the next thing to do is to balance the equation. We see that we have 2 nitrates as a product, so we need to have 2 nitrates in the reactant side. So we would put a 2 as the coefficient. The same with hydroxide and the hydrogen. So this is the balanced equation. We need to separate the ions in the aqueous solution, so anything that is aqueous stays as an ion. So we have 2 hydrogen ions, 2 nitrate ions, 1 barium ion, and 2 hydroxide ions as reactants. And then in the product side, the barium and the nitrate stay aqueous, so they are also ions. Water, the formation of water is stable, so water is our product or the result of our reaction. Again, we identify these ions that are spectators. We see that barium and nitrate have not changed, so they're spectators. So the only ones involved in the reaction really would be the hydrogen ion and the hydroxide ion forming water. So we would write the net equation as 2H plus aqueous plus 2OH negative aqueous makes 2HOH or water, which is in liquid form. Now let's look at the last example. Sodium sulfide solution mixes with hydrochloric acid producing hydrogen sulfide gas. Again, the product is a gas, so we know that a double replacement reaction has occurred. First, let's write the formula and then balance the equation. We know that sodium is a +1 and sulfide is -2. So in order to form a neutral compound, we need to have Na2S. It's aqueous because it mixes in solution. We're adding that to hydrochloric acid. Hydrochloric acid is a binary acid, so we know we have an H and a Cl, and it's also aqueous. Then we have hydrogen sulfide in gaseous form, so it forms a gas, so we put a G as its state of matter, and we're left with 2 sodium chloride, which stays aqueous because they stay as ions. The next thing to do is to balance the equation, and so we put a 2 in front of sodium chloride and a 2 in front of HCl and balance the equation. So the next step is to write out the complete ionic equation. So we'd have sodium separated from sulfur because they're both aqueous. Then we'd have hydrogen separated from chlorine because they're both aqueous, forming hydrogen sulfide gas, and that's brought together as a gas, so we would not separate that out, but the sodium and the chlorine are still aqueous. So we see that sodium and chlorine are our spectator ions, and to write our net ionic equation, we just bring down the sulfur because sulfur is the part that's going to form the hydrogen sulfide gas, bring down the hydrogen, 2 H pluses, and together they form H2S, which is a gas. And again, that is the net result of this double replacement reaction. I hope this helps you to understand how double replacement reactions occur. And remember, the products are going to be either a solid as a precipitate, a liquid as water, or a gas. Those are the 3 possible solutions for a double replacement reaction. I hope this helps, and just make sure you ask me if you have any questions. Thank you. Have a great day.